Hello, everyone, and thank you for joining our webinar today. We know that you're very busy. Everyone's very busy these days, and we really appreciate you taking the time out of your day to spend the next 45 to 60 minutes with us. Our webinar is called Accelerating Supply Chain Optimization with Machine Learning, Graph Analytics, and Visualization. And we hope you find it insightful and interesting. Next slide. Cool. So I'm David Ronald. I'm Director of Product Marketing at TigerGraph, and I'm delighted to introduce Scott Heath. Scott is the Chief Revenue Officer at Expero, a TigerGraph partner, and is responsible for Expero's sales, marketing, and strategic business development efforts. On the average day, you'll find him on the phone, at the whiteboard, or just gesticulating wildly in someone's office. Scott got his start in high tech as an engineer at NASA, so that's very impressive, and quickly found his calling in sales and marketing. He has worked in the deep end of SaaS, enterprise software sales, and large expert services consulting. Outside of work, Scott spends a lot of time at Austin's new Land Surf Park, honing his pop-up, which I have no idea what that means.
He surfs.
I'm cool. A mountain biker,
yeah.
Scott. But I'm sure it's something very dangerous. He also holds a patent for his multi-rotor helicopter. I'm also pleased to introduce Michael Shaler. Michael is a colleague within TigerGraph. He runs partnerships for the company, having previously worked at industry leaders such as DataStax, NetApp, Symantec, and Microsoft. Michael is based in Boulder, Colorado, and delights in mountain adventures, including spending last weekend in Yosemite, bouldering, I believe, and often can be seen, doing these activities with his 14-year-old son and co-conspirator, Alex. Next slide. So, just some housekeeping issues, standard stuff before we get started. Of course, as is normal, everyone's phone is muted. That's the way things are done. But please don't take that as an indication that we don't want to hear from you. We would like this webinar to be as interactive as possible. And you can submit your questions using the Q&A button in Zoom. The webinar is being recorded and will be uploaded to our website shortly. My colleagues in marketing are very quick, and we'll often have that done within a couple of hours. And additionally, we'll email to you the recording along with the slides and any other materials that Scott and Michael want to share. And if you have any issues with Zoom, please contact us during the event, and we'll try to respond to them as quickly as possible. So with that, let's get the party started. And we'll turn to you, Scott, and we'll put you in the hot seat first.
You bet. Well, nice to meet everybody.
What are some of the challenges that supply chain planners face currently?
Yeah, absolutely. I think the takeaway here is that what we're going to talk about today is really at a high level, and then we'll sort of dig in a little deeper with Michael on sort of how do we get this done. But as we've all seen with COVID, where we're at today is no one knew what a supply chain was a year ago. Everyone today knows what a toilet paper supply chain means if it doesn't work. It's incredible now, everything from parts to cars to chips to silicone, and it all has been sort of put in the spotlight. And ultimately what happens here is this ability of visibility, right? Can I, number one, see what happened in the past? Can I find a pattern? Take the pattern, look at it right now, not just a spreadsheet that I had from yesterday, which in today's world means that it's already old. And then how do I have this visibility of what happens if I make more, move more? Where is it in the world? And that's really where we're trying to go here in this is this visibility. These stats are mind-numbing, right? The fact that this 69% of lack of visibility for what people are doing really leads to why did we end up where we all are still today? We're still coming back to where we were. That ability to responsively react is where we are versus proactively plan and alternatively source or any of those kinds of things, right? And it's an overall thing, right? It's not just simply SAP's fault. It's not JD Edwards' fault. It's not a human's fault. It's that entire chain of this visibility that is so problematic. And I think that's the real sort of crux of what this is. Well, it's not an easy problem to solve, right? When you look at what's involved, there are multiple pieces of that. I have to source the materials. I have to have bills of material. I have to make it. Then I have to move it and warehouse it. Then I have to distribute it and transport it. Well, the beauty of these, just even from these pictures, you can see they are natural graphs. Why is that? They're deeply connected. If I have a 3mm part over on the left, and it is in 1,000 SKU subassemblies, and those subassemblies are in 10,000 parts or end pieces. And now I want to go find out where are they today, either in a warehouse or on a transport. That is an enormous undertaking. It could take days or weeks, and then it may never be in real time. So the complexity that we start to see now is this or as we say, a 3-dimensional or 4-dimensional complex diagram. It's not just the parts and pieces. It's not just where they are in the trucks. It's not just the trucks now with GPS and routing. It's all of that together. How do I optimize to go do those things? This is a very, very large and complex business problem. And that's really kind of what we do at Expero. We partner with TigerGraph, who is the leader. Many times people will ask us as a partner, well, you know, there are other products out in the market. And the answer is yes, there are, but they are typically point solutions, or they're query only, and they only solve a very, very, very tiny portion of that, which is why when you see the complexity of the problem, you'll see why TigerGraph is such a revolutionary product to bring this to market. So why? Well, our first one here is the alternative problem. Every time I have a part, every time I have a piece, every time I know where it is, that SAP extract is every minute that I take a PowerPoint or a spreadsheet or an export or an XML file or whatever it is and try and do this what if, it's already old. Why not connect it in place? The other element that we just saw in that previous diagram is the graph could be thousands of nodes. And how do I simplify that in one query to be able to say, show me where all those 3mm parts are, or screws, wherever they may be, and all the subassemblies? What happens if I replace them? Can I get a more expensive part? Can I get it in time? This alternative question is one of the first sort of dimensions of this, is how do I do that? Well, a graph database does that extremely elegantly. It allows me to ask all the nodes, which are effectively that bill of material, and with a warehouse of where they are, and then maybe even what truck they're on. I'm able to do that in a graph in an extremely sophisticated and simple way, and in a speedy way as well. The next one is dependencies. What happens if I do this, but I don't do that? What happens if this happens and that happens and this happens? What you kind of see in the background there is I need to now start to find out what those options are. I may have 10 options. Only 8 of them are good and only 2 of them are optimal, but only one may be the right answer. And it may not be the one I thought, right? That's part of what a graph can also do as well, is surface those. I can ask the graph, which one is the most risky? Which of those options is the most cost effective? Which may be the most time sensitive or the best for my business? The human still is allowed to make those distribution or connections, and maybe I want to feed that back into that dependency loop to start to learn why that is so important. So again, graph databases do this at a very different way than our SQL counterparts to be able to do this as well. Now I have data everywhere. So great, now I have 10, and Amazon has taught us all this, right? Which is when I do what it seems to be a simplistic purchase, I want to buy a cool a toy truck online at Amazon. I am simultaneously searching inventory across multiple third parties across the globe. I want to find where that data is, right? That's what we've now been able to do, is go look for inventory in systems to give me in real time, how can I get this to me next day? We've all become so dependent on that Amazon model that the idea of having large siloed data, so a global manufacturing company that we've worked with, right? How do I look across their global operation for all their parts and sub-assemblies and all their third parties, et cetera? That's an extremely daunting problem for the rest of the world besides Amazon to go do that. How do I do that? Again, our friend Graph is able to connect the data, be able to do those other items that I mentioned in a very sophisticated and a very seamless way. We can still extract it in spreadsheets because humans like sheets. Humans like the data the way they see it. You can still see graph data in those kinds of interfaces. But the concept here is bring that data together, share the data, and then start to make real decisions in real time. This quick case point, and you've seen this on the TigerGraph website, which is taking those different elements that I just mentioned, is exactly what Jaguar Land Rover did. You can see some pretty pictures of basically how we do that, and I've got some demos here in a minute. But the point of this is take that power of machine learning, the intersection of that machine learning in a graph, and all of those different alternatives and capacity planning, those kinds of things, putting them all together is really what Jaguar did, right? Being able to do this in a timely manner, allowing laypersons in different business units, capacity planners, schedulers, product folks on the floor, et cetera. That's really what that is. And I encourage you to go out online, go look at that use case. And I think there's even some interviews and talks of what they did. But the point of this now is that is how we're able to take the materials and the products and all those things and connect them all together. Now, here's a picture of what they did, right? What it was is they had parts and pieces that were in different product lines. Now, what happens in those different product lines is, should I continue to use this seat in this example here, is maybe I have a sub-assembly that can be used across my products. Well, if one of my products is not selling as much as I want, but I'm selling more of another product, should I make more of them? Should I move that product? And this is that multi-dimensional graph that we can see here, is that even though it appears to be a completely different product, if done properly in a graph, I can see that, well, it's the same seat. I can reuse it and I've already got it. I just may have it labeled as a different SKU, or it may be in a different color, but I have lots of them and perhaps I can move it across my business. That saves me a huge amount of money from a cost of making or building, or going and buying raw materials, or going and talking to a third party to go do that. And what does that mean to the business? Revenue. I don't have to go do that. I don't have to go buy it. I've already got it. There may be some shipping involved in our cost impact, but it's much easier to ship it than it is to procure it, have a wait time today for somebody else's supply chain, right? So the beauty of the graph now is I can connect all of these layers in this to start to make a deterministic and a real-time outcome. Those screens that we'll see here in a minute will show us how we do that in a real-time manner that's quite simple and quite easy. Now, here's a poll question. So,
okay, so let me, at this point, yeah, let's give Scott a breather, and we'll ask our audience to, by the way, that was great, Scott, well done. Yeah. Thanks. So let's take a breather. You can catch your breath, have a glass of water, whatever, and ask the audience to chime in on this question. Which one of the following concerns you the most when optimizing supply chains? Choices are a limited granularity of data. Second, slow pace of digital transformation. Third, lack of actionable data and analytics. Fourth, risks associated with being single sourced. That's an interesting one. And last but not least, maintaining traditional inventory strategies. So let's push this poll question to the audience, and we'd love to have your insights.
Okay. Well, everybody is chewing on that one.
Yeah, so actually, while people are chewing on that, well, if you wanted just to, I was going to ask Michael a couple of questions.
Go ahead, please.
Yeah, give you a chance to chime in here. So Scott was just, sharing the Jaguar Land Rover story, and I was wondering if you could quantify perhaps some of the benefits.
Absolutely. So
to a manufacturer,
yeah,
like Jaguar Land Rover, the benefits of using these tools that we're talking about.
Yeah, no, Jaguar Land Rover is a great story because they're such a storied brand. They've been in business for so long, and they've kind of continued to produce some of the world's great luxury cars. one of the things that's striking to me is that, everything Scott has been talking about is visibility and kind of how to account for bottleneck detection and all the things that we're going to see from the demo. But one of the things that is interesting to me, and lack of actionable data and analytics is clearly the thing that we're talking about here. And seeing into the supply chain is so powerful. If you go back in time, Jaguar Land Rover really struggled. They had an existential crisis at the corporate level, which in 2018, they were losing about 358 million pounds. And most of that was because they couldn't see 89 days a quarter of where they were with their supply chain and what the challenges were. We're going to share with you that they had a lack of actionable data and analytics, and they didn't have the right platform. And so Scott's going to show us what that looks like. Summary is that we have transformed Jaguar Land Rover together with leaders on their side, like Harry Powell, who speaks so eloquently about this. But the summary is the digital twin that they built of their supply chain changed their business, and now is contributing 100 million pounds a year to, as estimated, to their profitability. Great. When people talk about digital transformation, rarely do you get such a clear story of like how things changed because they did things differently with their supply chain. Back to you, David.
Yeah, and in fact, just staying with you for a second, Michael. So, we've been using the phrase graph databases quite a bit. Scott's been showing us some pictures. Is there anything you wanted to add just to kind of to explain to the audience how a graph database may be different from other legacy approaches?
Well, if you think about
why they're hot these days.
Yeah, so if you think about what a supply chain is, you have assemblies with components that have suppliers and locations and constraints. And constraints can take the form of all of these challenges in terms of limited granularity of data, and but also part constraints, as Scott was just saying. Is it easier to source, or is it easier to build, or kind of what is the fast path to getting things back on track? The summary here is that being able to see into this, having supply chain planners being able to take action and actually interact with the digital twin of the supply chain in a manner that they've never been able to do so is profound. When they moved from their traditional tool set to Graph, they were able to build the digital twin of their supply chain and actually proactively anticipate supply chain requirements and have much better visibility into where they are with suppliers, their agreements, and avoiding penalties in their supply chain has been transformational. Digital transformation changed the company, and they're in a much better place as a corporation because of what they've done from a supply chain perspective.
Very cool. All right, Scott, back to you. I know you're eager to start the demo, but anything about the poll results here that surprises you, or anything you wanted to add to?
No, I think that's very telling, and that actually is our picture. So guess what we see in our first item, right, is many folks who have seen graph databases, and for those who are new to graph databases, we see this thing called a ball and a stick, right? It's called nodes and vertices. Well, that's not the only view, right? That is merely showing us how things are connected to other things. The first thing that we see here in this, and this is part of the TigerGraph supply chain toolkit, is very simply, there are many ways, and it depends on who you are. If you are an executive, you may see a dashboard. If you're a capacity flow manager, or a material flow, or a bottleneck detection expert or analyst, right? You may see all of these. You may only see one of these. You can see red lines or constraints where things are bad, right? These are called Sankey charts. You can see some of these node diagrams, et cetera. But what I'm constantly drawn into is that poll question. Show me what I need to spend my time on, not what I don't need to spend my time on, and show me the time horizon for what happens if I do or if I don't do these things. And that's exactly what we want to show now in a live demo. And so to Michael's point, here we go. Now I'm able to, in this case, I'm an executive, and I may be looking at things at a macro level. Show me my demand, show me my revenue, show me where the risk is. And that is an actionable outcome, right? If I don't do this, what happens? Well, the first thing that we can do is say, well, what is the time period that I want to do that for? Well, in this case, I may want to say in this time period, and it could be in the past, or it could be in the present. Now what I can do is I'm starting to see perhaps where these things like risk are. maybe I want to alter my personal risk for my line of business or for my product or for my area, right? Those different graphs that we talked about. In this, I can now come in and say, well, maybe I don't care so much about the supplier confidence or the distribution, but I care very much about shortage. And I actually do care very much about overutilization. I don't want my machines to be the bottleneck. Well, now what I can do with a graph database is I can run a real-time risk algorithm. I'm now drawn in to say, well, I have a much larger risk than perhaps I thought. Now I would like to dig in and ask the graph. Now in this kind of an interface here, TigerGraph is not the only perhaps element that's in here. We may have an SAP, we may have spreadsheets, we may have older systems, right? So these dashboards, okay, dashboards are fun and they're interesting. Now what I want to do is I want to stand on top of that. I want the graph and perhaps some of these other algorithms that we keep speaking of to give us deterministic outcomes. Take that data, Scott, in that time frame and recommend that if I don't have this in my operations, I'm going to lose money. So human, you should do something. Also, if I don't have these over here because of compliance or tariffs or whatever those elements are in here, you're going to lose $450,000, right? And then I can dig in a little more. But that's great, right? So now that I've done that, now perhaps what I want to do is I want to go see where are those products? Where are these bottlenecks, right? Oh, look, my product in this time frame actually has a connected set of data. Now we're going to dig into the graph. I see that I have parts now in the bill of material. Across the top, there's another dimension for locations or resources. This is that multi-dimensional graph. What I can now do is simply say, show me that part, show me this part, and perhaps show me that part. That's one dimension. I've seen, and again, I can do all these, right? And we can spend more time on this. The second element is I could potentially look at my locations. Maybe my locations also have issues, right? Maybe in a different time frame, I have this packaging problem. Well, now I have an overlap. I have two dimensions. I have a location, right, that may also have a problem. And then I may actually have the machines in our Jaguar Land Rover that are putting them together. Maybe I have time frame problems here. Maybe they're later in the phase, but it looks like I'm good, right? So what I'm able to do now in this very simplistic analysis is I've been able to look at 3 dimensions of a graph for bottleneck detection. I can come over here. And now what I'm doing is in that traditional ball and stick view, I can say, start to show me where these parts and pieces are problematic. Now I can lay this out in a much more pleasing way. I can color code this, etc. Now what I'm seeing is, well, it's this intersection of this product, the parts, and the location. They're all running through the location. So even if I got all the parts together, the dimension that I may not have seen in a traditional spreadsheet is this ability to say, if it all shows up on time in Houston, I may have another problem. So again, that's a very simplistic view. There's another way to do that, which is to put it in this sort of active scenario builder. In this case, I can see over here on the left that I have hundreds of parts and hundreds of pieces. And I can see over here that I have an unoptimized capacity or scheduling. I can see that I have a few of them that are in range. Now what I can do is I can come over here and actively alter these. And then you can see over here that I brought some of these down from yellow or red down over here. And the way that I'm doing that is by simply using the graph database underneath. These are just 2 simple, very simple analogies of how we would use the graph database and how the layperson or the lay human, if you will, is capable of seeing this from their standard or daily life. Now I can export these and import these. But again, these were meant as just a quick vignette of basically what we're doing with Jaguar Land Rover. So
hey, Scott, if we could just go back one
Sure.
quick step. So what you showed is amazing. How does a customer get started with this approach?
Fantastic. It all starts with simplistic use case. What is your use case? I would like to increase my material flow accuracy by 10%. I need to increase the velocity by which I can create a capacity planning model, right? That's really what Jaguar did, is they started very simple with, we want to increase use case. The second part to that is take the spreadsheets that you already most likely have in SAP or JD Edwards or your CRM of choice. And it may be a couple of larger spreadsheets for those different elements. And then we can take that and then ingest that into a TigerGraph model and then show you what I'm showing you here.
That's cool. And Scott, we just got a question from one of our attendees. And this is interesting because you just highlighted on your last screen kind of actionable alerts. And there's a question about what actionable alerts have to do with graph. The reference was obviously in SAP, you call that pegging. And how is this different? And how is it better from than traditional technologies?
So let's look over here then at this machine learning, right? The one thing we know about the advent of machine learning is the ability then that it gives us a lift. And what it does then is it may give us an accuracy of 10 or 15%. It may give us a speed of 15 or 20%. A graph algorithm can do that now in conjunction with risk analytics and prediction at a much higher rate, because I can look at all the permutations simultaneously in history in one query, in one line of GSQL code. I can now create that. I can also simultaneously write a second algorithm for recommendation and perhaps a third one for page rank about which one of those the human should do. So in that extremely simple screen that I showed you over there, I have done 4 fairly complex things that says, human, you should probably listen to me. The other thing that we can do is feed that back into the graph model to teach it what things may be less important or more important, to be able to do all the things over on the right. And then you saw the simplistic visualization, but then they fit those use cases on the left. So that's a great question.
What I hear you saying, Scott, is that the difference between what graph can do and what traditional systems can do is that we can go both upstream and downstream in the digital twin and ask what if questions, and do bottleneck detection and really start to change the interaction between actionable alerts and action taken in ways that traditional systems are challenged by.
That's exactly right. So this center one here that says network pathing, the ability to do that network and then even overlay it with geospatial or telematic data is now that game changer. I can run 10 billion permutations in a graph database in 20 milliseconds.
Yep.
Challenge anyone out there to do that in a SQL database, but I'm not picking on a SQL database, right? We still need SQL. We still need SAP. They do things differently. There are things that those systems do that graph databases don't do, but it's this 1-2 punch, this bolt-on mentality that Jaguar Land Rover used to say, I'm going to keep everything I already have. I'm not going to throw anything away. I'm just simply going to augment that with this new analytic pattern and capability with graph databases. That's the game changer.
That's a very good point. If I can jump in there, Scott, you've touched on. So I think what you're describing is that graph is not a rip and replace for these existing systems. They augment or complement these systems.
That's right. That's exactly right. And so that user interface that we showed, we may query your old Tableau system. We may query from your SAP system, and then we ask the graph, what is the best answer? That's the beauty of a graph, is you can ask it a question. I don't have to know a select, where, from, if kind of a question. I can say, show me all the places it might work. Tell me why they won't work and give me a risk score of what those are. And that's all I presented in that user interface. And that other user interface I showed you with the drag and drop is I can pull hundreds of levers or tens of levers or 1 or 2 levers and then ask the graph, and in real time, I can see something I haven't done before.
Very cool.
Oh, cool.
Now, Michael, over to you. So Scott referenced GSQL as he was speaking. Can you explain to the audience what GSQL is and how it's different from SQL?
SQL, as we all know, is a standard query language for databases that's almost 40 years old. And this goes back in time to Edward Cobb's paper on relational algebra. Where we are now, though, is that we can actually leverage and extend and augment SQL with graph semantics. And so we have a language called graph structured query language, which enables us to ask questions of the graph, as Scott was saying. We can create queries that ask, what's the shortest path? Where is my bottleneck? And we can do that in a way that leverages, a collective wisdom of many DBAs and other application development professionals. And GSQL leverages the same kind of fundamental structures as SQL, but it applies it with graph semantics. So I can actually start to then add to that graph algorithms. As Scott was saying, we can use PageRank to find, PageRank is a way of finding inbound connections, identifying and ranking them and weighting them, and saying, okay, this is my most important part, or this is my most highly demanded outcome. So the summary is GSQL is a Turing-complete language that enables us to have both queries of the graph as well as algorithms that are applied to the graph and drive insights and outcomes that are unobtainable by any other means.
Good, very cool. All right. So Scott has nicely teed up poll question number 2. Which is the biggest challenge you face when using AI ML in your supply chain planning? First choice, lack of sufficient training data. Second, lack of data scientists or engineers with AI ML expertise. Third, lack of features with high correlation to the outcome. Or fourth is a catch-all, not using AI ML currently. So let's begin the poll.
Great.
And we'd love to have the audience share their insights with us.
I'm really curious about this question. This will be interesting to see what the responses are.
Well, currently the third option's leading.
Interesting.
Lack of features with high correlation to the outcome, but that might change as more people provide responses.
And it's interesting as we start to see the intersection between data science and AI and ML. It's going to be interesting to need to educate business leaders and others, but also we are going to be Scott's going to talk a little bit more about the second question that came up, which is labeling optimization techniques and how network optimization is interesting in this supply chain thing. Oh, look at this.
Yeah. So Scott, anything surprising here, or do these align with what you would have expected?
No, I find it's actually really interesting in correlation to one of the questions that just came in live, which was this optimization technique. So solvers, unique solvers for fixed answers have been around forever. However, the traveling salesman problem has been around also forever. One of the unique sort of questions here is, do you solve it in math? Do you solve it in a sort of a generic solver that IBM and some of these other folks have had around forever? Or do you use this new method, right? Which is, as we saw, patterns and the ability to see a network is what a graph database is. And by the way, graph database has been around since Leonard Euler in 18 whatever it is. And the way that was originally solved, the only new vogue here is that we're sort of triangulating those solvers, those traditional IBM style ones. And it's not just IBM, there's many other ones that have been around for tens and tens of years to solve these seemingly fixed problems. But yet somehow there are these open questions of constantly dynamic or shifting or changing, which is what the traveling salesman is. There's now a new way to do it. And I think that's what we're inviting you to do, is simply look at a graph database. Go see this for yourself. Don't just sort of take the hype for machine learning, but that intersection of being able to run a smart algorithm for shortest path, similarity, any of those other kinds of algorithms that you can now interrogate that you can do in machine learning. And yes, there is always the hype curve of it will solve everything. The answer is nothing is a silver bullet, including a graph database. And yes, you heard that right. A graph database is not a silver bullet. However, it is a game changer if combined with machine learning and some of the things we talked about today from visualization, because it allows the human to get involved, to say that is important or that is not important. And there is complexity and depth That's the other thing that a graph database does. So that's a very long answer to your question, David.
But Scott, what I think is interesting is you identified a couple of technology themes that are interesting. So static solvers are one piece of it. We still rely on legacy and heritage systems to know that that's where we've been doing so much of this work. But graph really is complementary to both. Graph has the or GSQL at least has the ability to do a lot of that solver linear algebra that you're talking about. Plus, it is able to reach into those legacy systems and put it in context. And we have a much more dynamic view of this digital twin of the supply chain that really changes the game. So it's really exciting to see what we can do for supply chain planners that they could never have done by any other means thus far.
And the beauty is for those that are practitioners on the phone that are data stewards or data engineers, and for the folks that are machine learning and sort of the new version of that, and even the old school folks that have been doing the planning and the solving for hundreds of years, telling sort of the new guys, right, that look, we've been doing this forever. The answer is all can be brought together in that sort of new way of thinking, which is a graph. When you go look and scratch behind what it is the way we think of things. It is for those that are data folks, it's a logical data model. There is no physical data model. It's the same data model. It's the way those things work, which is why it's so incredibly fast. That's why looking at a logical data model that I showed in the one diagram that could be thousands of nodes deep, that's what the data model is. That's just a representation. And then alternatives is simply walking the relationships, and it could be any relationship, it could be the attribute, the size, the color, any of those things is incredibly fast. And so that's the other sort of triangulation here, is that terabytes of historical data are imposing, but terabytes of historical data in a graph database are actually sometimes quite small, relatively speaking, when you look at the way that the graph traversal works in the query. And that's why these visualizations are so powerful. A human many times just needs some amount of coarse and then ever finer tuning to make the right outcome. And then if the graph can learn that, it gets even better as well. So that's a very long answer to why this technology in concert with SQL and some of these other solvers are such the power here.
The digital twin closed loop is very powerful.
Let's move to the next slide, Scott, please.
Okay. All right. So with that, I don't know if there are other questions or other ones that are out there, David?
Not so far. I'm not currently seeing.
There we go. Next slide, please, Scott.
Next slide. Yeah, there we go. One more slide. Cool.
Okay, so I'm going to go ahead and jump in here real quick and talk about kind of some of the things that Scott was showing from a supply chain toolkit perspective. We have this notion of TigerGraph workbenches, which enable us to rapidly configure and deploy modern UI applications. And it's pre-integrated with TigerGraph. There's one bundle, it's fast to deploy, and it's easy to support. On the left, you see that, kind of where you can learn more about our toolkits on our website at tigergraph.com/toolkits. Next slide, please. And we have upcoming webinars that are around supply chain and logistics management with graph databases and AI. And that's being presented by Publicis Sapient. We have Amadeus Tunis, who's the VP of Data Analytics at Publicis, and he's going to be talking about that on July 8th. On July 13th, we're also talking about accelerating graph analytics to answer complex business questions. And this is from our friends at HPE. The product manager's name is Jing Li. That'll be July 13th. And then we're planning a webinar on August 2nd with Xilinx as well. Next slide, please. So if you have any further questions, if you have any further need to spend more time with us, Scott and David and I are all looking forward to your questions, and we want to make sure we do a great job of addressing them. So I think that with that, we're going to wrap up and address more questions. I'd like to kick off the questions with Scott. Scott, where can I do this? Does it have to be on premise? Does it have to be on the cloud? Where does this work?
Well, the good thing about TigerGraph is, basically we'll all meet you where you're at. So some people are on an early exploratory journey. to the cloud, we can meet you there. We're basically working hard to be in either your private cloud or the generic marketplace. So that's sort of option number one. The other option is let's do it behind your firewall. Maybe you have radioactive data or information that you don't want to have elsewhere in sort of what you're doing. Maybe you have one location, or you may have more of a diverse global version. Happy to do that there. So really the answer is wherever you're at, we'll come meet you there.
Okay, cool. And so speaking of meeting you there, I know that a lot of our customers have, we've already heard questions about SAP and others. If you have an SAP system or a JD Edwards system, how do you kind of get what's in there into the graph?
Great question. Most of what we see then is sort of the first stage is data integration. 90% of the time, it sounds really silly, it's a spreadsheet. We see that 100% of the time, right? There are many multiple flat file extracts, and quite frankly, it's just the easiest way to do it. We see that all the time. We can do that at a cron or a batch schedule capability, and that's easy to do. The second method is more traditional ETL, so a Talon D or an Informatica or any of those kinds of ilk where you're actually truly inserting some logic. Great, we pick up existing ETL programs, and TigerGraph has a great interface to how to do that, and we can do that on a scheduled version or an ad hoc where you push a button. And then the third version is a more sophisticated Kafka or a queuing system where we can do that. TigerGraph comes with a Kafka adapter. So it's really whether you're trying to do it in real time and you want to be more sophisticated, or all the way down to a spreadsheet. And those other screens that I showed you, you can even do an ad hoc spreadsheet load if that's where we need to start as well.
And what's interesting to me also is like when we were hearing from Jaguar Land Rover about their journey to the supply chain digital twin, they tried very hard to fit supply chain into a large cloud data warehouse. And you know, when they actually finally got the query written, it took them weeks to complete a query, or at least the query ran for weeks. We don't actually know if it was completed or if the data was correct. What is a reasonable kind of expectation for some of these more complex solver-like scenarios where you actually have to do linear regression and actually do all the linear algebra behind it? Is it going to take weeks to run a query that draws on the spreadsheets that came out of legacy systems?
The answer is by no means. That's not even really within the realm of this. Most of what we're talking is depending on, you know, the largest that we've ever seen. You may be looking at minutes. Many times it's sub-second, and there are multiple ways on the back end side of this. So TigerGraph comes with a high availability, the ability to partition, do different kinds of locations, meaning you may have factories in different places where they can run and then replicate and connect, right? So we're no longer constrained by a single box. We're no longer constrained by sort of throttling of queries to sort of have different boxes with different queries. With a TigerGraph now, you're able to do it all. And the beauty of that is you can actually sub-segment it. So now,
Yep.
By doing some variability or some of those things from the user interface, like I showed there, is that if we give the human a way to filter that down, that's how they can do it in real time. So, you know, real time is not out of the realm. In fact, it's most of where we're going now. Now, you may be bottlenecked by those data imports, right? And some of the other things in your system, but from an analysis and a computation, it's typically in real time.
I think one last point I'd like to make that, you know, your demo showed in vivid detail, Scott, was that, you know, this is a scalable interface in terms of where we are in the organization. You know, a CEO can see this and say, oh, that makes sense, and a junior planner can also see it and help it make sense. It's such an exciting breakthrough for us to have the combination of visualization, graph plus machine learning AI all together in the same view.
Yeah, and I think that's important then, is when you look at that path from executive to line of business to planner, right? That's really what those toolkits bring to the table, is that ability to touch the elephant, if you will, in a very different way. Everybody has a different view, as you saw. There's a dashboard for different folks, for S&OP planners or capacity, et cetera. And everyone now has the ability, and they may never know they're touching a graph database, right? That's the other sort of takeaway here, is you don't need to call it out just to beat them up with a graph. The answer is to give them a deterministic, as the original poll question was, give something actionable, do it fast, and do it in a way that's accurate to allow that so that you can make a business change. And that's really what 2020 and COVID taught us is if you don't have that, it could mean the end of your business. And I think that's the core takeaway here is it all starts with a quick a walk and understanding of graph on some of the ways. And Michael, maybe a question back to you is where do they get started in some of the cloud starter kits?
Well, it's interesting. So if you go to TigerGraph Cloud or tgcloud.io, you can see some of our toolkits there, and you can actually take TigerGraph out for a spin. You can take a look at what it, kind of a simple representation of how to do some simple supply chain optimization, cost analysis, and if you go to tgcloud.io, if we go back one slide, please, Scott.
Sure.
One more, please. There we go. So that's where we can go. TigerGraphCloud.com/toolkits. You can see the toolkits. You can actually jump on them on the cloud. Free to use and free to explore, and at no cost. So we're really excited to be able to present this, share this with our fellows in the our fellow team members in the supply chain world, and we're excited to be able to share this with all of you. And we really do appreciate your time today. So thank you very much, everyone. David, back to you.
Let me just also thank Scott.
Yeah, you bet.
For providing a wealth of insightful information and a very cogent demo. Thank you for joining us, Scott. And also to you, Michael, and your almost, I would say, encyclopedic knowledge of all things graph and more. So thank you for joining us today too. So if you actually just go back to that last slide with the email addresses, Scott. Yeah, I'm sure the one before. Yep. I'm sure Scott and Michael would love to hear from you and to continue your journey about learning how graph and visualization and more can help with supply chain optimization. And as Michael said, we, all three of us, Scott, Michael, and myself, want to thank you for joining us today. We know you are busy, and we thank you for taking 45 minutes out of your day. And hopefully you found this webinar to be insightful and informative. Thank you.
Thanks, everybody.
Thank you.